All right, and welcome back. So today we are going to be talking about what is called a scatter plot and what is called a trend line. A trend line goes hand in hand within scatter plots, but a scatter plot is just a collection of data that people are finding that they put onto a coordinate grid, where we're going to be having a lot of different points of our data that looks kind of like it's going together. Sometimes it doesn't look like there's anything that we can deduce from it, but a scatter plot is just when we have a lot of data or we have multiple points of data that we want to analyze together and say, okay, are we seeing any overall patterns? So that is what our goal today is going to be able to describe what we're noticing within a scatter plot and be able to draw and predict a trend line. So without further ado, let's begin. So within scatter plots, we have something that is called a correlation. And a correlation is one way to describe a relationship between two sets of data. This is real life data that we are going to be talking about. Normally, we can have time, we have money, we can have weight, height, we have anything that we can use to describe real life examples. We are going to be putting into a scatter plot and seeing if there's anything that we can deduce between it. Saying, hey, is there a relationship that we're seeing between our independent variable and our dependent variable? Are we seeing that as you get older, you get taller? Are we seeing anything? Can we make a conclusion? Is there a correlation between those two sets of data? So there's three different types of correlation. The first one is called a positive correlation. And what that means is as one set of data increases, the other set is going to increase. The graph seems like it goes up from left to right. So it starts a little bit lower on the bottom left, but it keeps going up and up and up to the upper right-hand side. That's a positive correlation. We're saying, hey, we're seeing that there is a relationship and it has a positive growth to it. We also have what's called a negative correlation. Well, we have positive, so we should have negative. A negative correlation says that as one data set increases, the other set decreases. And the graph seems to go down, from left to right as we look at it. Well, if we look at the graph, we're starting up very high in the upper left-hand corner, and then we're dropping down to the bottom right as we move, going from left to right. And we're saying, okay, there's still a strong connection between these two, but as we continue through our graph, we're decreasing the value. There's still a strong correlation, it's a negative correlation because it seems to be going down. Also, we have what's called no correlation. When we have a scatter plot that doesn't seem like it has any connection to be made from it, we call that a no correlation. The data shows that there is no relationship between the sets, right? There is no relationship in the time it takes to, grow a certain type of fruit compared to no, I don't know. But there is no relationship between the 2 points of data that we are trying to analyze. So we would call that a no correlation because the graph has no pattern. And sometimes we're going to be asked to identify the correlation between things, to take a guess as to what we feel we would have to say. It's going to be a positive correlation, a negative correlation, or no correlation. So there's an example provided. It says identify the correlation you would expect to see between the number of grams of fat and the number of calories in different kinds of pizza. Well, when you increase the amount of fat in food, you're also increasing the number of calories in that. So they're both increases, both sets of data, the data points that we are analyzing here, the amount of fat and the calories, they're both increasing at the same time. So we should expect to see what's called a positive correlation. It's positive because they're both increasing at the same time. Now, consuming all of this additional fat and additional calories, we think in real life is not a good thing, right? It's not a positive thing. But when it comes to the mathematical analysis of it, we would be a positive correlation because we're seeing both of those data points or the sets of data increase at the same time. As we increase the amount of calories, we increase the amount of fat. As we increase the amount of fat, we increase the amount of calories. So we call that a positive correlation. Awesome. With that in mind, please work on problems 1 through 4 on the guide note sheet and resume when you are ready to move on. All right, if you're listening to my voice, that means that you have finished numbers 1 through 4 on the note sheet and you're ready to move on. So now is what we're going to be talking about, a trend line. So by drawing this trend line, we're able to make predictions. Now, I want to preface by saying no one's trend line is ever perfect. Trend lines are very, very difficult to create in like an exact moment because we're looking at data and we're analyzing and we're predicting. We're making a strong educated guess here. Trend lines are never going to be spot on, but it can show us the trend of our data. Saying, oh, as this increases, that increases, and I can make a prediction. So that's why we have these trend lines. So below it says a scatter plot shows the relationship between a man's height and the length of his femur, the thigh bone. Based on this relationship, predict the length of a man's femur if his height is 160 centimeters. So we're given a graph over on the right-hand side. And the first thing that we want to do is we want to draw that trend line. We're given this graph over on the right-hand side where it happens to have all of these different points of data, all of these coordinate points that represent the height by the femur length. And we want to create a line going somewhere in between there. Your line should have about as many points above it as it does below it. And it may or may not pass through some points, which is where I'm saying there's a lot of guessing here, but it's educated predictions where we're trying to show that we're seeing a trend. Everyone's trend line is going to be a little bit different. So our predictions are going to be close, but never probably the exact same as the entire class. So when we make this line, we just want to see, okay, is there a line that I can draw that seems to have the same number of points above it as it does below it? Well, above it, I have 1, 2, 3, 4. Below it, I have 1, 2, 3, and 4. So I have 4 points above, 4 points below, and I'm going to use this trend line to now make a prediction. So step 2 is I'm going to go from 160 centimeters on the x-axis up to the line. Well, I find 160 on the x-axis and I go up to it and I say, all right, now I hit the line, just like we did when it came to graphing functions and saying, hey, analyze this function and say, what would the y value be if your x value is blank? Well, here we're having x value of 160 because that's what represents the x-axis. And we go all the way up until we hit that line and we say, okay, it's going to be somewhere between 41 and 42, but it looks to be very, very close to 41. So I'm going to say that the femur length is going to be 41 centimeters. By using the trend line, we're able to make some predictions. Now, these might not be exact, but they're going to be close enough that way we can try to make some connections between these the sets of data. So again, everyone's trend line is going to be different, but we want to try and draw a line that has the same number of points above the line as it does below the line. And we can use that to make some predictions. And our predictions might be close to each other, which we hope they will, but sometimes we have some weak correlations that make those trend lines be very, very wonky. But right now, what we wanted to talk about is how we use a trend line to make a prediction. And again, when we draw a trend line, we want to be going all the way through the data set, want to have about the same number of points above it as we do below it. That way we can get a fairly strong trend to make an even stronger prediction. Awesome, folks. Good job so far. So please now work on problems 5 through 6 on the provided note sheet. If you have any questions, please jot them down as we will go over them in class. But have a great day, folks. Keep up the great work, and I will see you soon.